All right, can you guys hear me? All right, good morning. My name is Wade Wegner. I'm a technical evangelist at Microsoft on James's team. And you're actually going to see me twice today. So I'm talking this morning about Windows Azure Storage. We're going to talk about the highly scalable storage service. And then this afternoon, I'm going to give a talk where we're going to talk through some of the higher level services provided by the platform that gives you capabilities for accessing, securing, and scaling applications. But this morning, we're going to start off with storage. So one other thing that I wanted to mention is one of the things that I get to do that's kind of fun is I'm on a weekly show on Channel 9 called Cloud Cover. And Steve Marks and I, Steve Marks is part of the Windows Azure marketing. We talk about everything, everything under the sun when it comes to the platform. In fact, this week we covered a new sample we released called BlobShare, and it's all about storage. In fact, we have a great editor who put together a good video. And so what I wanted to do is, I thought pictures and sound would explain blobs and storage better than I can. So let me run this real quick for you. Here's your tip of the week.
Every one of you watching this screen, look out. Because soon, very soon, the most horrifying monster menace ever conceived will be oozing into this theater. There's no stopping the blob as it spreads from town to town.
All right, kind of silly.
And we're back.
So at any rate, we're going to be talking a lot about storage, blob storage, tables, queues, and I just wanted to share that. So if you get a chance, check out Cloud Cover. We go into depth in a lot of different areas. And so back to storage. So the Windows Azure Storage Service is actually a service that runs on Windows Azure. It runs on the compute runtime as well. And as part of that, it's a highly scalable service that you can use to store all kinds of types of data. So it could be data related to images. It could be structured data that you want to throw up into tables. You could even use for queues where you might want to start pulling together some sort of a asynchronous workload pattern where you want to offload some things somewhere else. And so we're going to talk through all of that. Essentially what it is, though, it's an API and a surface that you can use within your apps. It's scalable, durable, and available. So what I mean by scalable is that we actually use this service and find ways to scale your data massively so that if you use the service as it's intended to be used, we can actually serve up your data very, very fast and very rapidly. And as your load and users increase, we can scale out to meet those needs. It's also durable in the sense that every piece of data that you store within Windows Azure Storage gets replicated at least 3 times. So that even if we have internal failure with hardware, if a resource goes down, if something happens, we still have other replicas of that data that's available. So it's extremely durable. And in terms of availability, it's available anywhere that you can actually communicate over HTTP. All the APIs are available over REST. So anything that can talk HTTP and REST can interact with Windows Azure Storage. The other thing to note, and James covered this, is since it's a utility model, you'll only pay for what you use. So you will only pay for the files and the data that you put within Windows Azure Storage. You're not going to pay for the storage account in and of itself. It's only for what you put in it. There's also going to be some other costs as well, such as network bandwidth, consumption, as well as transactions. And we'll get to that later on in the day, I believe. And as I mentioned, everything's exposed via REST API. So you can not only access it from within your compute instances up in Windows Azure, but you can also access it from anywhere else. So you could build a local client app that runs on your PC. You could build a service that's communicating from your data center up into Windows Azure Storage. So anywhere that you can talk REST and HTTP, you can interact with the Windows Azure Storage service. Now, the top level thing to be aware of is that when you start working with Windows Azure Storage, you're going to create a storage account. And this is a globally unique name that belongs to you when you create it. And this is how you address everything within your storage account. When you create this account, you'll specify a location where this account will be created. So you'll go through, you'll create your storage account, and you'll choose a region, and you'll choose a sub-region. So within each region, we have 3 regions worldwide, James mentioned. Within each region, we have 2 sub-regions. And so you'll choose one of those, and that's where your data will be created. Now, as part of this, you actually can optionally turn on the Content Delivery Network, or the CDN. And the CDN gives you a way to take some of that data that you have stored within your account and start replicating and caching it closer to your users. And I'll get into some of the specifics there a little bit, and we'll talk about TTLs and how you get that set up. But note that we do have 24 additional CDN nodes worldwide that your data can be cached so that that data gets closer to your users. Now, the last thing, James went through a lot of compute, and one thing that's important to understand too is you can specify affinity between your storage accounts and your compute. And what I mean by affinity is you're essentially telling us that this storage account will be working with this type of compute, so that when we deploy your services, we not only deploy them in the same data center within the subregion, but we also can deploy those services and that app close together within the data center, so that we even reduce the types of network hops going through load balancers and so forth within the data center to optimize the experience for your application. Now, when you create a storage account, you want to be able to communicate with this securely. You've got different ways of interacting with it, like you'll have private data and you can have some public data. But when you interact with it, you'll actually do it securely, and you do this through two keys that you'll get. They're 512-bit keys that you'll use to sign requests when you start interacting with the storage service. I actually have a real quick question. Does anyone here know why we give you two keys instead of just one? In case you forget one, you can use the other. Actually, it's for key rolling. A lot of customers have security policies in place where they'll need to do a key roll like every 90 days. And if you consider if you only had one key with which to sign your requests in order to interact with storage, when you rolled it, you'd have a period of outage until you updated your compute and applications to use the new key. So you can actually use the secondary key and update your application so that when you roll or reset your primary key, your application still runs. So that's actually why we have two keys. Now, within each account, you can have up to 100 terabytes of data. So there's quite a bit of space here. And again, when you create a storage account, you're not paying for 100 terabytes of data until you actually start putting data into storage. Now, just recently, in fact, some of these things are quite new. I think we announced some of these things even at Build recently. So if you haven't been paying attention for storage, you may have missed these. But we've introduced geo-replication of storage accounts. And what this means is that within a region, we will automatically replicate your data to another data center. And we do that for disaster recovery, so that if something happens to the data center and we need to, some catastrophic event occurs, and we need to switch over to another data center, your data has been replicated to the other data center within that region. Now, this is all done under the covers. It's not something exposed to you other than you can optionally opt out of it. But GeoRep gives you that security in that sense that your data has been replicated to it. So it's not only it's replicated in triplicate within the data center, but it's also now replicated to a different data center in case anything were to happen. We also introduced storage analytics, where you can start getting some insight into how people are using storage. So we have the concept of logs as well as metrics. Logs will give you the ability to actually take a look to see what types of requests were executed against your data, whereas metrics starts giving you information, some things like statistics and so forth in terms of how people are interacting with data that you have stored in blobs, tables, queues, and so forth. And then even more recently, what we've done is improved support for headers. For instance, you can load videos up in, or files up in blob storage. And one of the challenges we had until recently was if you started downloading that resource and it was quite large and something interrupted the traffic, maybe you lost network, we didn't have the ability to actually reset and continue that download when you regained network connectivity. Question? I think the question was, does the log provide you any sort of information about the user, IP address, et cetera? No, the answer is no. So we don't actually track that information. It's just information about what requests come in and what resources are being, but we don't capture any sort of specific information about the underlying user that's accessing it. Now, James showed you a lot of the local dev tools that you can use when interacting with compute. We also have tools for interacting with storage locally. And so you'll have the local storage emulator, which essentially replicates exactly what the storage service is doing, so that when you want to develop something and use Windows Azure Storage and development, you can do it offline on your machine, and we'll actually stand up the same APIs locally so that when you address storage, you can do it in a consistent way that you do when you do it against your storage account in Windows Azure. It's all offline. We actually serialize the state and store it within SQL Express or SQL Server. It's not what we use up in Windows Azure. The storage service isn't built on SQL Server. But locally, for your development experience, that's where we store the state for Windows Azure Storage. So this gives you a nice way to develop things locally. Now, I will point out that it is not 100% consistent between the actual running service and the local service. There are some nuances. In most cases, you'll never notice it. As you start doing more advanced things and trying out some different additional things, you'll start noticing some of the differences. The link that I include here, all you need to remember is GG433135. That's pretty easy. If you go there, it's going to actually enumerate all the differences, so you can take a look and see if there's anything that affects you. A quick tip for how to handle this, what I end up doing when I'm developing is I first always pretty much start out with local compute, local storage. And then when I'm pretty satisfied with the way things are working, I'll actually then switch from local storage to start addressing Windows Azure Storage. And that way, now I've got my local compute addressing Windows Azure Storage. And again, since it's HTTP-based, it's not a problem. It's pretty easy to do. And only once now I'm satisfied with the local compute to Windows Azure Storage, would I then go and deploy my local compute up into Windows Azure Storage. So that gives you a nice iterative approach to start looking at storage and making sure that the things that you're writing and doing work well. Now, one of the things that I mentioned is that it's a REST API, and as it being a REST API, pretty much any kind of native, you can use any kind of runtime in order to address it, so long as it has some sort of support for an HTTP client. We provide you a very good, rich, fully featured, well, it was fully featured until some of the updates, but we provide you with a client library in .NET. It's a great library. It's managed and produced by the storage team itself. And you can use this within your .NET applications so that you have kind of some strongly typed ways of addressing and interacting with storage. So it'll handle all the actual HTTP requests and address the APIs, and you can just use the API. Now, that's the one that we produce, but there's actually quite a lot of other libraries out there. I think half of them have been built by Steve Marks. But there's quite a lot. So in addition to the C#.NET library that I just mentioned that we produce and support, there's a library for Python, Ruby, Perl, et cetera, even Objective-C. So our team has built a fully featured native Objective-C library for Windows Azure Storage that you can use for iOS applications. All right, so I've mentioned storage, and we use the concept of keys. Essentially, what's important to understand is when you use the key actually will sign the request so that when you make the HTTP call up into storage, the storage service will actually take a look at the request and take a look at the signature that was embedded with it and validate that it was actually signed by the key that it had issued. So this is a way that it can ensure that someone that's addressing it actually has the right level of access and authority in order to do so. One thing to point out is you can address storage both over HTTPS and HTTP. Now, in a production environment, I can't really think of many scenarios where I wouldn't want to use HTTPS. It provides security over your resources and so forth. From a development perspective, it makes things somewhat difficult because if you want to use a tool like Fiddler and actually inspect the requests as they go back and forth, the request response, HTTPS just kind of gets in the way. So with development, I always develop using HTTP just so that I can inspect in case I have any problems as I'm interacting with storage. But then when you go to production, you can flip that over to using HTTPS so that you have a secure endpoint. With the keys, you can actually regenerate them, and I mentioned that we can do that because of key rolling. We can actually regenerate one of them at a time so that your applications never lose access to storage. And we also have a concept called the shared access signature. And what this does is allows us to define a short-term policy where I can give someone access to a secured resource without them having to know what my keys are. And it may sound a little confusing at first. I'll give you a demo in a moment where I think it'll really reinforce what this is. But just think about a shared access signature being a way to give someone access to a secure resource for a period of time. And I think this slide got out of order. I probably should have started with this. blobs, drives, tables, and queues. Well, this is what makes up the Windows Azure Storage Service. Apologies about that. So we actually have 4 different constructs. Blobs, which I've already started describing, which basically you put files in there, videos, resources, and so forth. We have drives, which gives you a way to mount a NTFS partition, or what looks to be an NTFS partition. And I'll get into this in a little bit more depth soon. Essentially, this is great for applications you've written that use some sort of system.io or read and write to disk. And this gives you a way to still do that, even in an application deployed up into Windows Azure when using the storage service. And then we've got tables and queues. Tables gives you a logical way of structuring data in a very scalable way. And queues gives you a way to deliver messages that you can deliver offline, so some other person can dequeue that message and then process it. So within blobs, the way in which you start looking at blobs is you've got a couple of different pivots here. So at the very top, we have that globally unique account. With that account, you'll start creating containers. Containers are really just logical groups in which you'll start putting resources into a container. You can think of a container also as being a way of identifying security ACLs for those resources, since you can identify different rights at the container level. So you can start thinking of the resources that you might want to make public. You could put into a public container. If you want to keep some things private and make them not available, you can put them in a different container that would be marked private. So you can think of it as providing like a security boundary for your resources. Within there, you'll have your blobs. Not that big GUI thing we saw in the video, but these will actually be your files and so forth. Any kind of binary data you can put into storage. And then within the concept of the blob, we actually have 2 different types of blobs, a block blob and a page blob, and I'll get into what those are in a moment. Now, I said they're all addressable via HTTP and REST, and this is the URL. Essentially, you'll have your account name, whatever you define. It could be Wade Storage, it could be whatever. And then we'll have, of course, the rest of the URL, .blob.core.windows.net. You'll create your container name, which is that logical partitioning of your blob resources, and then you'll actually have the blob name. There's a number of operations that are available through the REST API. Essentially, you can do a put blob, which when you're uploading or putting a small resource, you'd actually invoke the put blob API. You can, of course, do a get blob, which would allow you to get a resource. And then we have some other operations as well, like delete, copy, snapshot, lease. Copy is what you'd expect. Here I have a blob. It's 200 gigabytes. Do a copy on it, and it just copies it over. It's very, very fast. But note, too, when you do a copy, you go from having, let's say, 100 megabytes, 100 gigabytes, whatever of stuff, and you're duplicating it. So you'll actually pay for twice the amount. Whereas with the snapshot, you can actually snapshot an existing blob and then only start capturing the deltas. So this way, if you just have things that get updated, if you just want to make some slight changes to a blob or some type of a resource, you only pay for the differences in that snapshot. So you can save yourself some money. And then we have the concept of a lease blob, which allows me to take a lease out on a resource so that no one else can actually update or affect that blob. And that gets very important when we get into the concept of NTFS drives in Windows Azure. Now, with blobs, you can actually associate additional metadata. And this gets really useful for pieces of data. So for instance, let's say I have a mobile application on my phone, and I take a picture and I upload it into storage. It's nice to use blob metadata in order to attach additional pieces of data, such as what was my location, what's the name of the file that I wanted to give it, those types of things, and then only have one operation for the actual put, so that I don't have to actually, from a mobile app, make a number of different transaction calls back to the storage service to first upload and then update metadata somewhere else. And since Windows Azure Storage also, there's a cost for each transaction against the storage service, being able to do that in one operation can actually save you money over the long term too. Metadata is also used elsewhere for like when you serve data up through the CDN to attach things like cache control and the TTLs associated to the item and so forth. So the metadata is a very important aspect of it. And then one of the other things that you can do is, you can also, within a container, basically identify a delimiter within the container so that if you want to treat blob storage similar to a file system and actually like say, here's, in my container I have this resource like a folder and then resources within it, you can define these delimiters, which you can then use as part of filtering within blob storages. within blob storage. Now, in blob storage, you can actually have a lot of containers. You can have multiple containers within it. And we give you one special container. And this is actually an important thing to make note of. And this is your root container. And so you'll address this as $root. Out of curiosity, does anyone know why we create this concept, this special root container? And what this does is, when you put stuff into the root container, it allows it to look as if you're actually attaching the blob resource right off of your account so that it doesn't look like it's in a container. Anyone know why we have the root container? I bet I know a couple people that do. It's largely for things like Silverlight and Flash that need to have a client access policy. Those things always need to hang off of the root of the URL. You can't actually attach it to something else underneath it, like a container name / and then you put your access policy. So by doing that, it lets us interact with storage via things like Silverlight and Flash and so forth. So the root container is an important container within Windows Azure Storage, and something that most likely, if you start interacting with the storage service, you'll end up leveraging. Most of this other stuff we went through, the blob container provides gives a container for blob resources. You can attach different ACLs to it and so forth. And then with the shared access signatures, it really gives you a way to provide some fine-grained access to the resources through a policy that can be short and long-term. So I think, here we go. So essentially, the way we do this is the shared access signature is a way of defining a URL that attaches some metadata about the type of access that you want to give it. So for instance, we will have a URL that will point to whatever /pic /image is, and then we'll attach this additional metadata that will specify characteristics like, when do you want to start giving access to this resource? When do you want to expire access to this resource? What type of permissions, read, write, create, delete. And then we include also this encoded signature. Now, the encoded signature is important because this encoded signature is generated through using the storage key, and we generate this signature here, this encoded signature, that's also passed in through the URL. Now, the reason we do this is once all this information gets to the storage service will take a look at all the additional data within the URL and generate its own signature, and then essentially compare it to the signature that you passed in. And this gives us the ability to validate that this is a valid signature and that we should give access to a secured resource. And what I'm going to go ahead and do is jump out and give you guys a quick demonstration of this. So I'm going to use a tool that our team has created called My Azure Storage, and essentially it's a tool that you can use to just interact with the storage system. And in order to use it, you'll provide your storage account name and then provide a access key. So what I'm going to do is in the portal that you probably saw earlier with James, I have a bunch of storage accounts here. And the name here for my storage account is Wade's Demo. And I'm going to go ahead and grab one of my access keys. I'm actually going to grab the secondary access key because that way I can very easily regenerate it later. So I've copied it into the clipboard. And then now I'm just going to come here, type Wade's Demo, paste this in. So you guys can give this a try. We do not store that access key anywhere. So if you wanted to give it a go, we're not actually logging it anywhere. But it gives you a nice, easy way, basically a UI, a web-based UI, in which to take a look and iterate over your resources. So I'm going to take a look at blobs. And here you'll see that here's my blobs. I have two containers. So I have a private container and I have a public container. And that's it right now. Now the private container is private because if you take a look at it, you'll see that the public access is turned off. So there's no access to any of the resources within the container. Now there's a couple of different policies that you can have. You can have a container level policy, which means that I'm going to give read permissions to items within my container, and I'm going to let people invoke a list blob against it where I can see a list of all the blobs that exist within the container. So this is nice if you want to make it public and then let people have some discoverability of the various resources you have within the container. Or you can choose to have it readable at the blob level, which means that you can't invoke a list blob against the storage account, and instead you can only access the blob if you know the URL to get to the blob. So it gives you a couple of different pivots with which to interact with storage. So this particular storage account, this private account, is private, which means if I take a look at this chrysanthemum, here's the URI that would be used in order to interact with this resource. If I come up here and actually paste this in, you'll see that the resource isn't found. And that's because it's a private container. I need to somehow sign the request in order to get access to that resource using my key, or I could use a shared access signature. Now, if I take a look at the public container, you'll see that the policy is actually defined at the blob level, which means that I can't do a list blob. I can't call the list blob API on the container to see all the blobs in it, but I can, if I know the URI to the blob, I can address it. So here, let's take a look at the resources that are in this container, and go ahead and copy this one. And you'll see that the resource comes up. So typically when you build an application, let's say a public website, you want to start putting some of images, CSS files, these sorts of things into the CDN, or some stuff that's static, you'll typically put them into a public container. That way, as the website loads up, you can serve these resources right from your storage account. Now, I've mentioned with the shared access signature, we can give people access, short-term access to a resource without them having to know the storage key. And there's two different ways to do this. You can actually do this at the blob level, which means that I can give up to 60 minutes of access to a resource, or I can do it via a policy defined at the container level. Now, the reason we have two different ways to do this is sometimes you just want to give short-term access to a resource, and you attach it directly to the blob itself. Now, the maximum amount of time that you can share it is 60 minutes. And the reason we do this is if for some reason that URL that you give out were to leak, you'd only have 60 minutes with which that resource would be available. Eventually it would expire and someone wouldn't have access to it. If you need longer term access, like you need to go past 60 minutes, that's where you'll actually create a policy. And I'll show you how both of these things work. So if I want to give access to an individual blob, I could come here to the chrysanthemum. And what I'm going to do is go to share. And I'm going to actually say, let's go ahead and share. I could specify a start date. So if I wanted to say, like, make this available starting today at midnight or tomorrow or next week or whatever, I can provide that start date and then an end date as well. And so here you can see that we're going to give access to this resource until sometime later in the day. I can also say the permission level. I only want people to be able to read that URL. Or I could even say through this shared access signature, give them the ability to do an operation like copy or delete or other things where they have write or delete access to the resource as well. So you can attach this type of permission level. Now once that does it, when you use these things, what you're doing is actually going to be generating a URI that's the shared access signature. So let me go ahead and I copied it. I'm going to paste this URI so that you guys. We're going to take another look at this. Hopefully it'll make some sense when we take a look at what we're actually putting in here. So if you take a look at the resources here, we've got a number of different things. Basically, ST is our start time for when we want to let this access begin. We have the expiry right here, which says we're only going to give access up to this period of time. Oops. This actually defines what type of resource we're sharing. Is this at the blob level or the container level? And then here we've got our permissions, and you can see RW is for read-write. And then here's the signature. The signature is what's generated by using the storage name and key against the options that are listed above. And again, we're passing all of this in the URI so that the storage service has this data, can generate the signature on its own, and then compare to the signature that we pass in. So if I now come to this URL, whereas before I didn't have access to the resource, well, let's see, oops. Oh, you know what? There's a unfortunate bug here where I mentioned that at the blob level, you can only have access for up to 60 minutes. And I think I made it longer than 60 minutes here. Let me see if I can change this to 10 a.m. There we go. Let's try that. The control itself is not... What am I doing wrong? Still? Oh, that's a good question. Where are we hosting this? AM, PM. All right. Well, you know what? Hold this for a moment. I actually don't. I'm missing something here. Let me show you the policy level because I can then extend it a little bit longer. So theoretically, if you create this, you can create that blob resource URI for up to a 60-minute access to the resource. What I'm going to show is another way to do this where you can create a policy. Now, a policy is something that's independent of the resources. So you can create the policy and then attach it to the resources individually. So here I'm going to create a new policy, and I'll just say read access. And I'll specify an end date of, let's say, 2012. And I'm going to give read-write access to it. And so I'm going to go ahead and create that policy. Now if I come back to the resource and go to share, I'm going to select that policy, and you'll see that these things are disabled. And right here, the policy is going to give us access up to 2012 with these levels of permission. So I'm going to grab that URL. Let me show you guys what this looks like as well. So very similar, except there's a little bit less data that's attached to it. Here we specify that it's still a policy at the blob level, and the identifier is actually read access. So we're telling it that we're using the read access policy that we defined. So now if I come back and use that, you'll see that the resource is available. Whereas if I try to access the resource directly, it's unavailable. So the shared access signature gives us some access to a resource, even though we didn't use this storage account key in order to access it. All right, so that's shared access signature. The last thing that I wanted to show real quick was the root container. So what I'm going to do is create a new container, and I'm literally going to call it $root. And we'll go ahead and add a resource into it. So let's grab some kind of a picture. Let's grab the Windows Azure picture. Say OK. Oop. I'm going to add that one more time because I did not include the extension. All right. All right, so now if I take a look at this and I grab this resource, I'm going to make this container public at the blob level. And then we should be able to see that. So here's the logo. What you can do, because we have this root, I can actually remove this now as well. And I can access that image directly off of the account. So again, for things like client, the client access policies and so forth, it gives us the ability to actually attach it to the URI directly. So that's just a quick look at some of the storage things. Let's come back and keep going through some of the other items. Now, I've mentioned before that there's two different types of blobs. There's a block blob and a page blob. And the difference between the two is really how you write data into the blob. With the block blob, what you'll do is you'll create individual blocks, and you'll upload them all individually. And then once they're all there, you'll commit them into your underlying blob. And this is really good for large files like videos and so forth that need to be streamed, so that you can, even in parallel, upload the additional block, all these blocks. And then when they're all there, you can go ahead and commit them into a singular blob. There is a size limit for a block blob of 200 gigabytes, so just note that. And the way in which you manage concurrency is through e-tags. So you'll actually need to, if you want to perform an operation and potentially update it, you'll want to check the e-tag to make sure that that resource hasn't been changed by some other operator. Now the page blob is different in the sense that it can write randomly to your blob entity, and as a consequence, it's really good for workloads where you're randomly writing to different places within the blob. And this is really important with drives, so I'll explain that in a moment. The size limit for the page blob is actually quite a bit larger. It's 1 terabyte. And we do have the ability to associate a lease to the blob. So you can have both pessimistic and optimistic concurrency with it in order to essentially lock access to the resource. So when looking at a block blob, here's kind of a nice walkthrough to understand exactly what's happening and what what underlying blocks are. So we're going to upload a 10 gigabyte movie, and it just so happens it's the blob. And we essentially want to eventually have a resource called blobname.wmv. And so what I'm going to do is break up the movie into a series of blocks, and then I'm going to start uploading these blocks one at a time, invoking the put block API. And we're going to keep doing this and over and over and over again until these resources eventually are all uploaded. And we get the very last one. And once we get that, we're going to call a put block list, which is the operator where you then specify all the blocks that you passed up, and you're going to commit them into the blob that you have in storage. So essentially, all of those individual put blocks could be done in parallel. And when they're done, then we're going to commit them into one resource. And so we're going to create the actual the blob.wmv. So this allows us to very efficiently upload these resources because we can do them in parallel. It also lets us have retry at the block level so that if something were to happen, it didn't interrupt the entire upload of this very large file. We just can do a retry of the individual block that didn't make it. Now the page blob, I said, is for random read writes. And so essentially with the page blob, the operations look a little bit differently. First, in the beginning, rather than waiting till all the blocks are there and then creating the blob, you actually first create your blob, and you'll say create a blob of up to 10 gigabytes. Now when you do this, we'll create the entity. However, you don't actually have data there yet. So when you invoke the create blob, or when you create the page blob, you don't actually have data within it. We just allocate and reserve that space. So there's nothing. So you're not going to be paying for 10 gigabytes of data because you haven't put anything there. But once you've created the blob, the page blob, now you can start writing to it and reading from it. So for instance, and when you do this, we always do it at a fixed size of 512 bytes. So what I can end up doing is issuing a put page operation where I can put data, bytes of data directly into the page blob and say start it at sector 512 and right up to 2048. I can then start it over again and go from 0 to 1024. I can update somewhere or clear it or remove that data. I can put stuff in. So again, you're seeing that we're interacting with the blob randomly across different sectors within it. And this is really important when it comes to, let's say, attaching a disk, through the disks, through the Windows Azure Storage disks, or drives rather, because anytime you're interacting with an NTFS partition, you're reading and writing randomly across that partition. And so the page blobs allow us to perform these random read-write operations. And so I can do a get across it as well.
Did you say pages could be 1 terabyte?
1 terabyte. Yep. Yeah, so you can go up to 1 terabyte for a page blob. Yep. All right, so I mentioned CDN before. CDN is really important when it comes to caching your data closer to your end users. Remember that we have 6 Windows Azure data centers, and your storage accounts are in one of those data centers. If your users, the further your users are away from that data center, the longer the times it's going to take for them to actually interact with your storage resources. So when it comes to things like images, videos, and other static type data, you can actually attach them to our content delivery network and then take advantage of the 24 nodes that we have worldwide. And it's a really simple operation to do. You can do it up within the portal. You'll essentially add the CDN to it. And you'll see down here there's a new URI that you'll use to start addressing your storage. And it's going to be an ID that's randomly generated, .vo.msecond.net. And you'll start using that to address your data so that via DNS we can figure out where the closest CDN node is and route you accordingly. You can also attach a custom domain name to it via a CNAME. So you can create your own CNAME like cdn.contoso.com and have your CNAME, the CDN piece of it, actually then resolve to whatever the CDN URL is. And so here's kind of a quick look at the value of CDN. So for instance here we've got our content delivery network, and then at the bottom right we've got Windows Azure Storage. And once we've registered for the CDN and attached it to our storage account right here, what we're going to do is try to serve up data within the images container. Now, note that you really only want to attach public data to the CDN because the CDN has no knowledge of public and private when it comes to resources. So you want to make sure that at the container level, you're making sure images are public. So now, when a user ends up going against the CDN URL, through the DNS, it's going to end up resolving to an edge location, so one of the CDN nodes, one of the 24 worldwide, and it's going to look to see if the resource he's looking for is available. If it's not, it's going to go back to the storage account, grab the resource, and pull it down to the CDN node and cache it there locally. And then once it's cached locally, there's going to be a TTL associated to it. and then it's going to end up getting sent back to the user. So at this point, the user actually, it took took a little bit longer for the very first user to get this resource because there's a cache aside pattern with the CDN where the user came to the CDN, the resource wasn't available, the CDN went and got it, pulled it down, and then served it up to the user. Now in the future, when the user goes to address that resource, it's going to be able to serve it up very quickly because that resource has been cached at that edge location. Now, after a period of time, the TTL will expire and the CDN will let go of that resource. So when the user comes to get it, again, it's going to have to go back to the storage account, serve it up, and then return it to the user. 1 second. And then eventually what could happen is it could be cached at the CDN based on the TTLs that were specified, but the resource could be removed from storage. And so in this case, the user will go to get it, and because it still exists at the CDN, it'll still be served up until finally the resource expires at the CDN and then goes to get it out of there and says, well, it's no longer in the storage account, and it'll issue a 404. So that's kind of the life cycle of the content delivery network. Question?
We initiate a flush or a drive to update those things in spite of TTLs?
So the question was, can we do a flush or somehow clear out the CDN? And the answer is no. So you can't actually use an operation to clear out the CDN. There's a couple of, we have another, there's another talk that we'll do, or actually I guess we're not doing it here, more of an advanced storage talk. And we talk about how you can start to create your blobs with different names so that you can start basically identifying them differently. So for instance, if you had an image that you wanted to rotate occasionally and it was important to be able to change it and then not wait for the TTLs, you could give it like a date or a timestamp or something like that, serve it up through a page, let's say it's a URL, and it would address that resource. When you want to change it, you simply attach a new, upload a new image with a new URL or URI, and then update your web page as well to address the new resource. So even though the old resource is still in the CDN and cached, any user that's going to access it through a web page and so forth is actually now getting the new resource. And you're still benefiting from having that data cached near the user. Now, I'd mentioned earlier with blobs, you have the ability to attach metadata. One of those things are the cache control to specify the TTL you want. So you can choose a TTL that's appropriate, make it shorter or longer. If you don't specify anything, we use a revolving heuristic where essentially I think, well, you put the resource into the CDN, and we'll check, like maybe, I forget exactly what it is, but like the first hour to see if there's a new resource. If it hasn't changed, then we'll wait 2 hours. And if it still hasn't changed, we'll wait a day. And eventually, essentially it'll get longer and longer. So if it's important to you, you'll want to specify your own TTL settings for it.
I have a similar question. So we have the CDN up and running in Azure.
Mm-hmm.
And the problem right now is we have, let's say, a lot of marketing collaterals are on Azure. And in the beginning, we decide that it's going to be, we have a cache control setting.
Mm-hmm.
And then we say it's for 6 months.
Yep.
Right? The TTL is going to
So 6-month TTL.
And then suddenly the business decides, oh no, we don't want that. We want it to be
Yep.
only 1 month.
Yep.
There is no way right now to go back and flush that out.
So basically, it's a long-running. You've got something with a very large TTL, and let's say 6-month TTL. The business decides that they want to change the resource. You don't have a way to flush it out. That's why I think this different pattern of specifically naming the resource and then changing it and updating the reference to the resource is probably the easiest and best way to get that instant ability to point to a new resource and have it cached. If we want to go, we can always, I'm happy to take it offline if you want to talk through some additional things as well. I actually have quite a bit of content to get through here as well, so I'm going to try to get through some of this. Next is drives. Now, I hope that the page blob stuff made a little bit of sense in terms of the need to have random read writes, because drives is all about randomly reading and writing to some type of an NTFS mounted resource. And so Windows Azure Drives is essentially created so that you can still benefit from a highly scalable, durable, reliable storage service, but address it the way that you typically would via system.io, where you can read and write resources. So essentially, you can mount a Windows Azure Drive to one of your role instances, like your web role worker role, and then address resources and storage through that drive using system.io. We have a driver that's loaded into the roles that essentially allows us to work with Windows Azure Storage as if it's a mounted NTFS partition. And so if you think about when you start doing system.io and you're updating a file or deleting it and you're doing various things against a drive, those are random read-write operations. And so that's why the page blob makes a lot of sense for it. Essentially what it is it's a VHD file that's mounted, or it's a VHD page blob that you end up mounting onto it. The main thing to note is you can only have one instance of the drive writable at any time. So let's say you had 5 web roles or worker roles interacting with this drive. Only one of them can be writable at a time, and we do this through the lease on the page blob. And the rest of them are in a read-only mode. And so, so only one can write at a time. One of the things that you end up doing so that you have like hot failover is all your role instances will always be trying to establish a lease, so that if, say, one of your role instances were to go down, the one that is actually writing to the drive, when it goes down, the lease will eventually expire, and then one of the other role instances will be able to essentially grab that lease and then be able to start writing to the drive. Let's see. Okay, so I got a little ahead of myself. Basically, and you can an instance can dynamically mount up to 16 drives, which is another nice aspect of it. One thing to note is it's the actual driver installed within the role instance that's actually translating all the I/O that's going against the mounted drive, and it's translating it into the REST API calls, essentially the put pages and the get page and so forth operations that are being sent back to the storage system for you. And here are some of the different operations that you have. And so here's a quick look at what happens here. Essentially, you've got this blob that you're going to mount as a drive. Now, one thing to note is we keep a local cache of all of this so that we can do very quick read and write access to it, and the local cache will keep track of that. And so anytime you end up doing a write, it's going to write to the drive and it's going to update the local cache as well as the page blob as well. And then later on, let's see here. And if you're read-only, you can end up actually doing a read directly against the local cache. And it'll also then, if it's looking for something that's not in the local cache, it'll check the page blob, pull it in, and then it'll update things so that the next time it's there. Very similar to the cache aside pattern that we saw in the CDN. So it's just a little local cache. And then it'll return the data. We have essentially an API for it and a runtime API in .NET that you can use within the client library. So here's some of the syntax that you'll end up seeing. And I talked through some of the failovers with it. So essentially, through leases, you can have role instances trying to establish that lease, so that if something were to happen to the instance that's writing to into the page blob, another instance can actually pick it up and move forward. Okay, so drives. We'll move on to tables. Now, tables, I want to point out right away, are not relational. Roger is going to talk about SQL Azure, and so when you want to start doing things like aggregations, sorts, joins, all that rich stuff that you love and want to get out of things like SQL Server, SQL Azure is really what you're going to be looking for, and Roger will talk through that and more. Tables within Windows Azure Storage gives you the ability to have highly scalable partitioned data that's semi-structured in nature. So you can see here, we have, again, our globally unique account name, so Contoso, and then I can define tables underneath it, customers' photos. And then within those tables, I have these these name value entities where I can start writing some type of structured data into the entity. Like I said, it's not a relational database. There are various ways of executing and interacting with it. So you can do create, you can create a table, you can query it, delete it, those sorts of things. And at the entity level, so the data that is put within the table, you also can do things like inserting, updating. We actually introduced recently an upsert, so that if you're not sure if that data exists or not, rather than calling 2 operations and catching the failure, you can just issue an upsert once. Actually saves on the transaction costs. And then we have other things as well, other operations. Now, one of the main things that I want to drill home for the tables is that I said that it's partitioned data, and we do that through what's called a partition key. So there's actually a couple of pieces of a couple of properties for every entity that's required. We have a partition key and a row key. The partition key is what's used to define how we scale your data. And I'll get into that in a moment because I have a nice, I think, graphic that'll make that easy to understand. But note that the partition key defines how scalable or how much we can scale your data based on the load characteristics that come in. The row key is a way of uniquely identifying that data, so you can put some information within it. And the combination of the partition key and row key uniquely defines that identity, or that entity. Also, we have a timestamp, and the timestamp is what you'll use to manage concurrency. It's exposed as an E tag, and so that as you're writing, updating, basically interacting with tables, you want to check that E tag value to see if it's changed since the last time you checked it. And it's worth pointing out once again that there's no fixed schema for tables, so you can define, it's very flexible in terms of the way you define the entities that you put within the table. So to reinforce that, here's a very simple table that's created. You can see we've got a first name, last name, and birth date. And myself and Nathan have entered the birth date as a date time value, but Nick has gone ahead and entered it as a string. Now, in a relational database, this could be a problem. Within Windows Azure Tables, since there's no fixed schema, this actually is not a problem. Now, of course, you need to make sure that the application that uses this data can handle this and accordingly. But within Windows Azure Tables, it doesn't matter. There's no fixed schema, so you can do this. In fact, it turns out that Nathan really likes to canoe, so there's additional metadata that's only been attached within the entity for Nathan. So it's a very flexible way of adding data into tables. Now, I talked about, one other thing too, is you can do querying against this data as well. Now, this is slightly not a very good example because it's not going to be particularly performant. This is where partition keys will come into play and some of the other row keys. But essentially, you could end up issuing a statement where you could query or filter based on things like last name equals and then a value. And then it would return that record. So when I talked about the partitioning, this becomes important when you get a lot of load. So imagine you have a lot of data and you have a lot of users coming and interacting with it. Now we need to figure out the best way to scale your data so that we can return it as fast as we need to. So this is where the partition key comes into play. So you look that with this data, we have a partitioning mechanism that allows certain things to be uniquely identified. So we've got some things partitioned by bikes, some by canoes, rafts, skis, etc. And as load increases and we're analyzing the load characteristics, what we can end up doing is partitioning this data based on that partition key so that now different servers within the Windows Azure storage system can start returning that data. So you can see we've partitioned based on that row key, and now different servers are responsible for returning data, for returning different data. So this is how we'll end up having that highly scalable storage service return your data as efficiently as possible based on the load characteristics. And there's quite a bit within the storage service in terms of analyzing the load pattern, so we figure out the best way to partition and return that data. All right, and then to wrap this up, we'll talk a little bit about queues. Now, queues, in terms of structure, are similar in that they're attached to an account. You can create a queue, and then you can add a message inside of that queue. And that message is up to 64 kilobytes of data that can be put into the queue. And then there's simple queue operations that you can use to get that data out. Basically, what this allows the queues really do is allow you to loosely couple your applications. Think about a web page, actually the one that James showed, where he uploaded a photo. When you upload that photo, you might want to do some processing that photo, create some thumbnails and so forth. And rather than tying up the UI and making that user wait to perform those operations, once the image is uploaded, you can put a message or an instruction into a queue and then have another process that's running in the background, let's say a worker role, grab the message out of the queue and take some sort of action on behalf of that work item that was placed into the queue. And so this not only allows you to decouple the various systems, it also allows you to have different pivots for scale. So for instance, you may find that your back-end worker roles are doing a lot of processing on images or some sort of other computation, and you can scale those independently of your front-end UI. Or similarly, if you have a lot of traffic and you need to scale out that front-end UI in order to return the responses and data to it, you actually can scale out that tier independent of the back-end processing. So it gives you a lot of flexibility in terms of how you couple the different aspects of your application. essentially, a couple of things to point out here. There's a number of queue operations. You can create a queue, you can delete it, you can get and set metadata at the queue level, not the message level, but at the queue level. And you can also clear out messages from a queue. At the message level, you can do things like put a message, get a message, you can peek into a message, you can delete a message, and update a message. One of the more important things to note with queues is that you need to make sure that your applications are idempotent. And what I mean by that is within queues, you need to make sure that your application can process data put into a queue more than once, because our guarantee on the queue is that your data will be read at least once. It is possible that a message could come back into a queue and then get processed more than once. And so essentially what I mean by that is imagine you've got multiple worker roles checking into a queue for some sort of data. Worker role 1 grabs a message as it's been placed into a queue. When it grabs it, it's going to set a timeout where until it commits or deletes the message from the queue, it's essentially just been temporarily removed. So that if that worker role were to go down and not complete its operation, the timeout would expire and the message would go back into the queue, and then your other worker role would be able to pick it up. And so some of the processing may have occurred, and so you need to make sure that the applications you build are idempotent in the sense that it's okay for them to process that message or that instruction more than once. And this is just part of the reliability and guarantees that you'll get by using the queues. You can guarantee that you'll process that message at least once. Could be more. And that's it. So we went through quite a bit. So there's a lot of fundamental things to know about Windows Azure Storage Service. There's four of these different types. We've got blobs, drives, tables, and queues. And each have their different uses. If you're programming with .NET, you can use the client library and have everything strongly typed. Or you can go and communicate directly against the REST APIs as well. And we can actually point you to tomorrow, if you come to the workshop, to a number of hands-on labs that provide a nice ramp for getting started with Windows Azure Storage. And that's it. So thank you very much.
What should I do? We're going to take a 15-minute break.
Okay. We're going to take a 15-minute break. So I think there's drinks and
back
food.
at 11:30.
So we'll start again at 11:30.
Good job, pal. How you feeling? Crappy.
Yeah, that was not my best.